In this video, we're going to talk about the 4 levels of measurement. The first level of measurement that we have is called nominal. And a nominal level of measurement is data that is characterized by or consists of names, labels, or categories, and these names, labels, and categories, they cannot be ordered. Right? There's no natural ordering there. And so an example of something that would be nominal would be something like eye color. You can't order that eye color. Right? You might say, oh, well, we could go through and we could order it based on an alphabetical order. That's pretty natural. And I would say, okay, that's fine. What language are we going to write those colors in? Because depending on what language we write that in, that order is going to be different, right? So we have no natural ordering there. When we do have a natural ordering, it no longer is nominal, but then it becomes ordinal. Right? So this is characterized by data that can be ordered but differences between data values are meaningless. So if we were to talk about like threat levels, threat level 1, 2, 3, or 4, we could say, oh, a threat level 4 is worse than a threat level 3, but 4 minus 3 being 1, that doesn't really tell us anything other than it is 1 threat level higher. Right? So if we have threat level midnight, that it might be worse than a threat level red. But other than knowing that it's worse, we can't take a difference between these values. As you might imagine, the next level of measurement is going to make those differences meaningful. Right? And so here we have an interval level. So here the data can be ordered, and the differences between data values are meaningful. However, when we have this interval level of measurement, there is no natural 0 point. So we have no natural 0 point at which none of a quantity is present. Right? And so something like temperature in either Fahrenheit or Celsius. When we look at temperature in either Fahrenheit or Celsius, this would be an interval level. We can say something is 10 degrees hotter or 37 degrees hotter or colder, and that's meaningful. However, if you're talking about temperature outside and you're saying one day is comparing a day that was 100 degrees to a day that was 50 degrees, it doesn't make sense to say it's twice as hot, because when it's 0 degrees there doesn't actually mean doesn't represent the absence of a quantity. If we were talking about temperature in kelvins, then kelvins, absolute 0, that is saying the absolute absence of heat, right? And so in kelvins, that makes sense. But here, not so much. And then our fourth and final level of measurement that we take a look at. This is a ratio level. In our ratio level, this is characterized by data that can be ordered and differences are meaningful. There is a natural 0 point at which none of a quantity is present. Because there's that natural 0 point, ratios of data values are meaningful. So things like height. A person's height, you might say, there's not anyone that has 0 as a height. I would say that's true, but our height, if there was someone that was 0 as a height, that is the complete absence of height. There is no height present. And so from there, we go up. And so whether you measure a person's height in inches or in meters or in miles or in feet or in yards, whatever unit of measurement you might use, you could compare two people's heights. The differences might not be the same between those two people's heights because of the units. However, the ratios would be the same. If one person is twice as tall as another person, it doesn't matter whether they are measured in inches or feet or miles or millimeters. Right? That doesn't matter. So height, you might have things like length, weight. Each of those would be examples of ratio measurements. All right, those are the 4 levels of measurement. We will talk to you again next time.